This is Ship It with Justin Garrison and Autumn Nash, a podcast about everything that happens after Git push. Ship It is brought to you by Fly.io, the home of changelog.com. Launch your apps close to your users all around the world. Learn how at Fly.io.
Hello and welcome to Ship It, the podcast all about what happens after you Git push. I'm your host, Justin Garrison, and with me as always is Autumn Nash. How's it going, Autumn?
Good. How are you? How's your Sunday going?
It's Monday, by the way.
Oh, damn it. It feels like a Sunday.
We are recording on Memorial Day, a day off for us in the United States, but yeah, it does feel like a Sunday because tomorrow is back to work, back to school. So
it's totally it's a Sunday.
But that was a 3-day weekend, so FYI.
It's the only Monday that doesn't feel like a Monday.
Yeah.
And it hasn't sucked.
Oh, but don't worry, it sounds like a double Tuesday. It feels like a double Tuesday tomorrow.
When you have double the email.
Yeah. The people that were either out of the country, don't have it off, or just were deciding to catch up on a Monday. Yeah, you get to figure that one out. So it'll be fun. This is our 16th episode ever since the reboot of Ship It. And we just wanted to talk to everyone, let you know that we are adjusting the format a little bit. Thank you everyone for sending in feedback and for letting us know what you did and didn't like about the show and recommending topics. All of those things have been awesome. We've been reading all those emails, but we are going to change up the format just a little bit to help the streamlining of episodes for us to record them. And also because we kept feeling like we were pushing people we were interviewing into smaller schedules. Either the interview would go long and the episode was an hour and a half long, or we were trying to tighten them up and say like, oh, we can't talk about that really cool thing that you do. So let's just ignore it and then move on. And so we don't want to do either of those things. So we're actually going to cut out the beginning links of the week segment that we were doing. And it's going to be part of our normal rotation for outro section. So we're still going to have an outro, which will be a variety of different things. We've had lots of good feedback on those outros, but we'll mix in links of the week. If there's something that Autumn and I want to talk about or something that we found really interesting, that will be our outro segment. And that's just what we're going to do.
Also, thanks for listening. Like, we've gotten such cool listeners and like feedback on Slack and Twitter and all kind of Blue Sky.
Yeah, it's been awesome just seeing people really enjoying the show come back and listening to the topics and then just connecting with different technologies and what people are doing. And that's just fun to see. Like, we're kind of introducing people to stuff. And I love doing that because we're getting introduced to it and then we get to share.
And then when people are so excited about things, it's so much fun when like they're like, I totally saw that video, and you're just like, exactly.
Yeah. So this week on the show, we have Danielle Lancashire, who is a principal engineer at Fermyon. And Fermyon is a WebAssembly cloud hosting platform that you can run your WebAssembly code and they will run it for you. And so we get to dive into how that works. What is WebAssembly and how the back end of Fermyon works and how kind of you can run this stuff in either the Fermyon environment or even what they ship as a Kubernetes interface for it. So it has a lot of variety there, but if you've never used WebAssembly before, never tried it, aren't familiar with it, don't worry. The outro, we also have you covered. We're going to go over the WTA outro of what the acronym and explain some of the stuff because there's a lot of terms and stuff in the interview. We try to explain those as well, but we're going to go to them a little bit more in the outro just as a review so that we can make sure everyone's on the same page. We want to be inclusive and help anyone, even if you don't know the tech or you're familiar with it.
I had no idea before we were doing research for this episode. I had no idea what WebAssembly was at all.
Yeah, it's pretty new.
I found out it has just as many awful acronyms as Kubernetes and all of your crazy stuff.
Yeah, it's just WebAssembly's acronyms are usually in English, and that is a benefit for WebAssembly.
Not like, let's do everything in Greek and then take all the vowels off.
Yeah. Trying to make abbreviations and acronyms out of Greek words is a little bit more difficult to wrap your head around. So.
In Kubernetes defense, all the names sound cool. You're just like, but what are we talking about though?
Yeah. For sure. What is an Istio? I don't know, but it's
like, it sounds cool. Like, it's just not giving you a lot of information, but you know.
Yeah. One thing that is nice is like the terms kind of line, like Kubernetes as a helmsman. You're like, okay, what does that mean? Like, well, Docker is ships and there's containers. Like, okay, like you drive it. All right, I see it. But yeah, like that doesn't always line up. Right? There's always some gaps there.
It is nice that it's themed. It's like one of those like Pinterest birthday parties you throw your kids, but like with technology, like you got a theme going.
Yeah.
You could stick to it. It's cool to make stickers with.
So let's jump into the interview with Danielle, and then we will come back for the outro and explain some more acronyms all around WebAssembly.
What's up, friends? This episode is brought to you by our friends at Neon, on-demand scalability, bottomless storage, and database branching. And I'm here with Nikita Shamganov, co-founder and CEO of Neon. So Nikita, imagine you are a tour guide. Give me a tour through the world of Neon.
So let's look at a modern developer. As people say, never bet against JavaScript. So more than 50% probability this person is writing JavaScript and TypeScript. Using React, Next.js, deploying their code on a platform like Vercel, and really care about design. So working with Figma, working with a local designer, or maybe starting to work with an AI designer and using technology like Vercel just shipped called V0. And then like you got to store data somewhere. So you go to Neon or use Vercel Postgres, which is powered by Neon. You push a button and now you're able to write and read from Neon, and then that kind of just works out of the box. The majority of your time you spend crafting your application, crafting the front end, and then the database is just kind of there and just kind of works. And you don't think too much about it. And when you run previews, when you run next versions of your software, you can send your collaborators, your other engineers on your team, or your product managers or designers a version of your app, the version of the future that you want to debate, that you want to comment on. And it's fully sandbox, from your front end to back end to the database. That's like a good part of this world. The world is obviously much bigger than just building front end apps. There's also back end apps, there are Python apps, there are Java apps, and all of those things. We're perfecting the world for the world that I just described. And we think that the rest of the world will follow. And the rest of the world is Java apps, Rust apps, backend apps, queues, scheduling, AWS Lambda, Kubernetes, containers. Again, the tech world of the backend is just enormous. But I think perfecting this first world that I described will create a standard in developer experience that the rest of the developer world will just follow.
So you have Vercel Postgres powered by Neon. You've got Neon as an integration to Vercel. You've got Neon out there at neon.tech as self-serve where anybody could just go and sign up and start up right now. You're optimizing for this new standard, but what's the response been like? What's the community saying? What's the community's response?
We are lately onboarding close to 2,500 databases a day. That's more than one database a minute of somebody in the world coming to Neon, either directly or through the help of our partners. And they're able to experience what it feels like to program against database that looks like a URL and the program against a database that can support branching and be like a good buddy for you in the software development lifecycle. So that's exciting. And while that's exciting, the urgency at Neon is unparalleled.
There you go. If you want to experience the future, go to neon.tech, on-demand scalability, bottomless storage, database branching, everything you want for the Postgres of the future. Once again, neon.tech.
Hello and welcome to the podcast, Danielle Lancashire, a principal engineer at Fermyon. Danielle, welcome. Tell us about yourself.
Hi. You'd think I'd be prepared for these things ever, but I never am. I am by heart a photographer and then by trade a software engineer at Fermyon, where I work a lot on bringing WebAssembly to the cloud, which is a sort of interesting concept if you think about it. A lot of people think WebAssembly and hear browser, but it turns out having a like portable binary format you can run anywhere is kind of awesome.
And I want to dive really deep onto WebAssembly and Wasm in general, because like portable binaries, we've kind of like an ELF binary is pretty portable, right? Like how is Wasm different and what does it do?
I mean, an ELF binary is portable across like some number of like Linux distributions, but the second you want to talk about Windows or Mac OS, or like moving to, ARM or RISC-V or wherever else, well, not so portable anymore, unless you, do Apple things and Rosetta everything.
The struggle is real.
And so by building to a like portable intermediary format like WebAssembly, you can then run those on literally anything. So I have a demo cluster where I take the same WebAssembly application and I have a Kubernetes cluster that's RISC-V, ARM64, and, AMD64. And the same thing just runs across all of them with no changes. And that is the point where a lot of people go, oh, wait, I didn't have to spend like 6 months supporting different architectures and testing a bunch of like really cursed dependencies. And that's pretty awesome.
And how does that actually get accomplished, right? Because like you have containers which can be portable and you just build them twice for the architectures. And then at the runtime layer says, oh, I need the ARM or the RISC or the AMD, whatever version I need as the executable. Give me that one. But that's like build time, you build them multiple times. And Wasm is different, right?
Yeah, with WebAssembly, you build once, and then it's the job of the runtime to either build a specialized version for your platform or just interpret the WebAssembly the same way that, Node interprets JavaScript. Although I think it also does some pre-compilation and stuff, whatever, too. Because, nothing is ever truly interpreted these days. So you either, like with Wasm time, which is what we use, there's a thing called CraneLift. And what CraneLift does is build optimized local native representations at instantiation time, or lazily and JIT it, but after the first request, everything is pretty fast.
And that sounds similar to what we had in the past with something like Python, right? Like Python, so an interpreted language, it's like, hey, the runtime handles the architecture and my Python code doesn't have to change to run on different architectures. And then at runtime, it does some compilation for my architecture to run.
Exactly. With WebAssembly, you end up being a little bit lower overhead. If you compile C to WebAssembly, I think the most recent set of benchmarks I saw was like a few percentage points slower than running a native binary. But the other joy of that is you can do that for any programming language that can eventually support WebAssembly. So like be that Python, Ruby, Swift, JavaScript, Rust, Go. You can truly do this like polyglot thing. And when you bring in things like the component model, which is one of the sort of more recent evolutions of WASI, you can even have different components of your application be written in different languages. For example, if you have a tooling team that writes a bunch of stuff for doing observability or interacting with different APIs or whatever, you can call those from any language that your team is writing software in.
Can you take a step back and just describe WASI for us too, the interface?
Oh yeah, should probably do that. WASI is bringing I/O to WebAssembly, basically. So WebAssembly by itself can't really talk to the outside world. It's just an executable format, and you run in the browser, so you might extend some like JavaScript browser APIs into a WebAssembly binary, but it's mostly like pure put something in, get something out, not much else.
And the runtime is responsible for like moving that data between, right?
Yeah. And WASI takes, the WebAssembly format and brings a standard set of interfaces for doing a lot of the stuff that software needs to do. Sort of like, POSIX APIs are to everything else, but it doesn't quite copy those because we bring in a capability-based security model. And so you can say that like at runtime, this WASI application can, talk to these set of files and these set of files only, or make outbound requests to these specific IP addresses.
Is that enforced in the runtime?
Yeah.
Okay. So the runtime knows, hey, you have this rule set that you're allowed to do, and I'm only going to allow you to do those things. Whereas like again, an ELF binary or a Python scripts, like I basically have the whole machine, unless I'm containerized some other way, right? Where I have to isolate my space with a different mechanism.
Yeah. All WebAssembly stuff is pretty much default deny. And you have to sort of incrementally give it the things you want it to do. And that all happens through a standardized set of interfaces that is WASI. That's a bunch of people coming together and figuring out sort of the right way to do things for both from a security perspective, but also like efficiency and standardization of like, what is it mean to talk to a database?
Right. WASI stands for the WebAssembly system interface, right?
Yeah.
That's that like spec that says, hey, these are the things you can do if you need to open a socket to listen on a port or something. You do that through the WASI interface.
Yeah, exactly.
That's interesting. I never heard about the extensions to be able to write multiple like components of the app in different languages to kind of glue those together and at that point it compiles down to a single Wasm binary.
It can compile down to a single Wasm binary, or you can have those multiple binaries sort of like composed together. So they call each other and sort of expose interfaces that the other thing can talk to. Kind of like a library, but while being language agnostic.
The language agnosticism of it limits what you can do, right? Because it's like we have this runtime that's default deny. We have JavaScript and Python in the wild, wild west of like what can compile into this. But there has to be like some subset of like, this just doesn't work in WebAssembly, right? Because like those two things aren't the same.
There's definitely a lot of things that you can't just take as they are today and run within WASI. Like WASI doesn't yet have a standardized threading model. It's something that's being actively worked on this year. It was like a really big topic at Wasm.io a few months ago. And there's sort of a lot of stuff that's like early but coming. But there's not a lot of stuff that you couldn't theoretically do.
Now, what software are you responsible for? You work at Fermyon and you have like this Wasm cloud that you offer. What do you run, or what software are you building there?
I've worked on a big mix of both our cloud and also the bringing WebAssembly to Kubernetes stuff through SpinCube. A lot of that is sort of mine and people I work with's domain, which is a mix of, for Kubernetes things, we built out a Containerd shim. So Containerd has pluggable runtime environments, like execution things called shims. And there's a project called RunWASI that exists to let you write shims that run WebAssembly code. And so we have one of those for running spin applications, which is Fermyon's like WebAssembly. I guess framework is kind of the right word. It's like kind of a runtime, but also kind of a framework. And like the community hasn't really standardized on language for that yet. And then sort of an operate.
Why would I want that? Why do I want to run WebAssembly binaries inside a Kubernetes cluster? I have containers, and I can put those languages in a container and run them, and the runtime can also handle architecture differences, right? Because I could build it twice, and then I can pull it down and run it on ARM versus AMD, whatever. What other benefits does a WebAssembly binary have in this case?
So one of the big ones is density. So when a WebAssembly application is doing nothing, it is actually doing nothing. It's a bit of memory and effectively no CPU. That's pretty different to a lot of other sort of serverless programming models, where like you potentially need to be running fairly heavyweight software and potentially two applications to have that programming model. In some cases, that's like 10 plus X density improvements, which if you're worrying about, cloud cost or managing your like cloud infrastructure, that can make really big differences, especially at scale. But beyond that, the security model and being able to cleanly express what you want your applications to do gives you a lot of really nice benefits, partially for things like multi-tenancy, especially if you ever need to run like an untrusted application in your environment.
I've used in the past, Cloudflare Workers is WebAssembly based, and they have some really good blog posts on like how they would speed that up and why they use it. And I know there's other WebAssembly companies that use more, I don't want to say lighter weight, but different scheduling engines like Nomad. to be able to speed up execution time for scheduling, because that's like a built-in stack. It's less flexible, but also faster than Kubernetes in a lot of ways. All those things like build layers of where do I want to control this thing, right? Because I can control, again, at the container layer, I can say, you're not allowed to talk to this other thing, or you're not allowed to run this kernel argument or permissions, whatever. And then at the WebAssembly layer, I can do it at the application and say, hey, the runtime will enforce, I can't read this file. And then at the cloud layer, right, if I'm running all this in an AWS account, like I have IAM on top of that, that says, somewhere in there I have some Linux permissions, all this. Like, it seems like security is good in layers, but at some point, like, you have to pick the layer that you want to operate in. And I guess the more portable you need to be, the closer you want that to be the application, right?
Yeah. In our cloud, we actually use Nomad.
Okay.
I'm a little bit biased. I'm a former Nomad maintainer. I'm, now also a Kubernetes maintainer, but like Nomad has a special place in my heart.
Yeah.
But the sort of security in layers and the application layer security is really nice when you're building a platform like Fermyon Cloud or like something like Lambda or whatever, because we run thousands of applications on every node. Like, looking at that from like the Kubernetes world is like, what? What are you doing? Like, how? And we can do that partially because of the guarantees we get from that execution layer. Because we can map, you deployed this application as, team foo, and you only have access to these things. And you've declared that this application should be able to access, this database or this key value store, whatever. And then at a runtime layer, we can guarantee that they are the only things you can talk to, which is pretty revolutionary in a lot of ways. Like, I worked at Circle CI when we moved from doing a lot of stuff in like, pre-configured LXC containers to Docker and bring your own container. And the amount of work we had to do to isolate anything sensibly was like monumental in comparison to what we had to do for Fermyon Cloud. And trying to understand what anything needed was basically impossible. And now it's your application self-describes what it needs. Like, it tells us that it needs this thing. And we can go, yes, you can have this thing. And we can guarantee at deploy time that your application has access to the things it needs to or doesn't, and bring that conversation much earlier in the loop, as opposed to doing, like runtime profiling to understand what syscall something is making.
Right. And I think that's just that approach of starting with the default deny and building up is so much easier than, not easier, but it's a different approach than what we have with containers, where we're taking all of the kernel calls and we're dividing them. And we have all these namespaces that we say, hey, we take a big machine with a single kernel and then make it smaller into smaller chunks. And then how do we divvy all that up? And if you, at some point you want the more secure thing, and so you're going to say, hey, I just need these 10, 20, 30 things versus I don't need these hundreds of things, and how you approach those things are very different. Can you walk through, if I create a Wasm binary, what is the process for me going from the spin command to an executable inside of Fermyon? Like, I can call it and I get data back from it. Like, what are all the layers and steps there?
Spin cloud deploy.
But like, what's the stack?
Oh, yeah.
Like, I know, like the experience is great. Like, the experience is very much like, hey, you just hid like 100 different things from me.
Oh yeah, it's an adventure. So we have a front-end application that's written in C# of all things, which has been interesting to relearn.
Interesting.
So that's our like what I call front-end monolith. It's the API service that anyone using Fermyon Cloud interacts with, and is also what serves our UI. Then there's what I lovingly call the backend monolith. And that's like relatively standard Go service that mostly just talks gRPC. And that is basically the cloud control plane. And that's what goes and, when the front-end app receives the request to deploy the application, make sure it's all stored in an OCI registry. And, when all of that stuff is done, it goes ahead and gives the sort of backend monolith the manifest after, sort of validating permissions and stuff.
Is that manifest a nomad job, or is that it's a custom thing?
That manifest is a rendered version of some TOML.
Okay.
It's a data structure that kind of goes, you want these key value stores and they're bound to these names for this application. and you want like this database, and you should respond to things at this address, like that kind of stuff. Then the backend monolith goes and runs a nomad job that will go and deploy your WebAssembly app on some subset of the nodes. And that goes and does the, sort of pre-compilation step, getting everything set up. And also goes and like make sure the databases that you wanted exist, and make sure that your like applications token has access to them. And that sort of all gets handled in the runtime layer. So your application doesn't know that there's an authentication token, for example.
Handle that outside the app so I don't have to deal with it as a developer.
Yeah, the idea is like you should focus on writing code, and it shouldn't matter what is backing any of those things, which is a programming model that a lot of people really love. And we've had it repeatedly sort of happen over the years, like especially when sort of Heroku took the world by storm and did a lot of stuff for you, but left you with a lot of sort of vendor lock-in. The joys of WebAssembly and standardizing on a bunch of these interfaces is that you can get that programming model without necessarily being tied into a platform forever. Because, the same thing you run on your laptop when you type spin up, and, by default binds a lot of things to being in SQLite, but will also let you talk to Cosmos DB or DynamoDB or whatever it is. Works the same way in Fermyon Cloud as it does in anywhere else.
That layer of abstracting what I'm talking to happens at the runtime, right? So like the runtime shim is saying like, oh, you wanted a key value store. I give you a key value store. You don't care, right?
Exactly. Then the rest of the cloud rundown as it is, we have a multi-tenant key value store that's actually backed by Postgres.
Postgres runs the world.
Oh yeah, Postgres I love. Like Postgres, you can make it do anything if you're willing to be cursed enough.
The way that you held your chest with Postgres, like we're going to be like, we're right here. Like,
it's the best. It deals with all the pesky persistence things, and all we have to do is give it a sensible API.
It's so underrated, I think, because it's not the cool hip thing, but it's crazy how many things run on Postgres or how other cool databases.
Yeah, you don't want your database to be cool. That should be the most boring piece of your stack.
But people always want the newest, coolest thing in tech, but it's funny because those newest, coolest things usually are on Postgres anyway.
My personal feeling about infrastructure is it should aim to be as boring as physically possible.
Can all of tech adopt that? Because it would make our lives so much easier. Like simple, boring, tested things. And then please document it.
Like our tech stack is EC2 instances running in an auto-scaling group, Nomad, Console, Vault, and like the shiniest, newest thing we have is Trafic.
That fancy load balancer there. You got a reverse proxy that's like, hey, we got. And I guess that has a lot of integrations for like where it routes the traffic, right? It's just like, oh, this is multi-tenant routing for that, right?
Yeah, Trafic is basically there because it can talk to Console. It has like reasonably sensible routing rules that it can derive from Console, and it can generate TLS certificates. And then there's, Postgres and SQS. Because like SQS is the best service that Amazon have ever released, and nothing comes close to it.
Someone recently described EventBridge as SQS with a hat, and I was like, yeah, that sounds so accurate. This is, I love it.
It's funny though. This is gonna sound weird, but like in fashion, right? Like even the most expensive things are usually simple, right? Like they're either good quality, simple, or almost like weirdly like junky and simple and expensive, kind of like what we were talking about earlier, like when people buy like super expensive stuff in Seattle to like go hiking, and then they wear expensive hiking stuff everywhere. So it's funny, like I think sometimes the best stuff in tech and like fancy stuff in like fashion in a lot of places, like you almost pay more for simplicity because it sticks around longer,
Oh yeah. Like I also just love how stable this is. Like I've been focusing a lot on the Kubernetes things rather than the cloud for a while. And so the last time I meaningfully touched our cloud infrastructure was February, and it just keeps working. And now I've said that there's going to be an outage like the second
just because
we
you
finish
said
this podcast. But like that's fine, because if I only have to care once every few months, I'm fine with it occasionally being a problem.
Not just that, but if you build it like with simplicity, it's not hard. Well, I mean, I'm not going to say it's not hard, but it's so much easier to debug when it's not a million fancy things that are not like if you're using something that's been around for a while and used a lot, at least somebody else has come into that problem and someone on Stack Overflow is complaining about it and going to give you a couple ideas how to fix it.
Yeah. Like our biggest single node scaling bottleneck in the cloud is that like, because we health check applications relatively frequently, console starts chewing a lot of CPU because if there's more than about 8,000 applications on every node, it starts consuming about 4 CPU cores just to do health checks. It's like, okay, we know that's a problem. We could eventually fix it.
How do you do health checks for 8,000 applications on a single node from console? Like, because they're not long running processes, right? Like these are all essentially functions. So you have to start them to health check them, right?
Yeah.
So you're just constantly like starting and stopping all of these workloads on a single node and saying like, yep, you're good still.
Yep.
How do you do that efficiently though?
I mean, partially because like running WebAssembly stuff is relatively efficient to begin with. It takes less than a millisecond for a WebAssembly application to start.
It's essentially forking a process, right? Because like the runtime's there, it's always running, and we have this binary that it's just going to like execute. And so we're just like, oh, fork the process and kill it, right?
I mean, because a lot of this happens within Tokyo, which is a Rust equivalent of like Go routines. You know, it's a lot of green threads more than anything else. We don't even need to fork.
It's not even a fork. Okay.
Yeah, it's kind of awesome. The biggest bottleneck is, for that part in particular, is just disk I/O. Because a bunch of stuff is kept M-mapped, if it actually got like purged from memory, then we have to reread it from disk.
Yeah. That takes a long time when when you're used to having something in memory. Yeah.
It takes like a few hundred nanoseconds.
No big deal.
What are you doing in the Kubernetes side? Because you say you mainly deal with both, and like your infrastructure for the cloud portion is a known set of interactions with EC2 instances and some services. But what are you building and doing on the Kubernetes side?
I'm working on two things on the Kubernetes side. One is SpinCube, which is, you know, open source, runs every application in a pod, sort of gives you, you know, the things you're comfortable with, but also a bit of something new. But the other thing that I'm working on is basically what we call Fermyon platform for Kubernetes, which is taking a lot of the ways we run things in the cloud and moving them into Kubernetes, which has its like own set of trade-offs, because rather than running every application in a pod, we run one pod per node, which changes a lot of the sort of Kubernetes networking model. I spent a lot of time this week having to very quickly like learn the endpoint slices API and how like all of that should work if you're running it yourself.
That was my first thought, was like when you say you run thousands of applications per node, and you know, like the trade-offs there of architecture of like Kubernetes typically requires one IP address per pod. And I'm like, you're going to run out of IP addresses real quick. Like that's just not going to happen. And so now you're taking that and you're saying, hey, you know what? Like we can't do one application or one IP address per WebAssembly application because it doesn't need an IP. Just the runtime needs the IP, right?
Yeah, exactly.
And so at that point, you take your runtime and shove it in a pod, and then all of the applications that run under that are all under one IP address, but it routes and does all the stuff to say like, hey, we're just going to fork or run these threads, running these executables inside of this one container. And now if I'm debugging it from a Kubernetes admin perspective, I say, hey, I want to get my pod, but that's just a runtime. How do I say I want to get my application? I need to go a layer deeper than that.
Exactly. So like my prototype for this runs 3,000 apps on every node with basically zero noticeable overhead. So at the networking layer, that still means making a service for every application, but an application might be multiple WebAssembly components. Because you might want like a different component per like set of routes or something in a HTTP application, depending on how you want to architect your application. So we create a service per application, and then we bind the runtimes that are running that application to the service when the application is ready.
And those are just pods behind a service. In a Kubernetes case, this is like I have a service and that routes to pods. And then the runtime itself says, oh, I was called on this path or this host name. Let me start that application for you.
Exactly. And it works surprisingly well. It's one of those things where, like, you think something's going to work, but then you try it and it works better than you expected it to.
And you're surprised.
Yeah, I mean, I generally sometimes have some self-confidence issues. So, like, when, like, this, like, idea that I thought was vaguely cursed, which is, can we put our cloud in a box? Turns out the answer is yes.
And why? Why put your cloud in a Kubernetes box when you're doing everything with EC2 and Nomad now?
It turns out a lot of people really like the programming model of serverless, but between sort of like potential vendor issues, cost, whatever else, means that they're looking for something else. And WebAssembly, in my opinion, is basically what serverless should be. You completely separate away the runtime from the application. And so, like, you don't need your application to bind to a socket, which you still have in a lot of, other serverless environments. Combine that with WebAssembly's, security capabilities and the fact that it actually does scale to effectively zero, you get this sort of perfect coupling of infrastructure that can support the programming model. Whereas before we had a programming model, we were shoehorning into infrastructure that couldn't really handle it. And that meant that, we were paying huge startup costs if you wanted to run anything in Lambda or other similar stuff, because you've got to go fetch a container, start a VM, launch the thing, and then set up all your network pathways. And that's in response to a request. Like, I never understood it. I was like, I like the idea of serverless, but I could never get behind ever shipping something in a serverless way. There's just too many drawbacks.
There's a lot of network and infrastructure overhead to take some data and send it back. And like you mentioned, like a container or a zip or whatever, however we're packaged is probably larger than you need for your application piece of it. The runtime being part of that as well. If I have a Python Lambda versus Java Lambda, like I have to have that runtime as part of it versus compiling Wasm into like a single binary format that can all be understood from the different languages. But yeah, like, and also like the VM side of it, right? You're like, we have Lambda has Fargate that runs, creates a VM and then network and maybe a container on top of that. And how you isolate all those things is very slow when you actually look at all the components involved. How would you describe, and I wanted to bring this conversation this way because we're almost out of time, but I wanted to get Autumn's opinion. Like how is WebAssembly different than Java? Because I feel like some of the promises that I hear over and over again in the WebAssembly world have been what I heard 20 years ago in the Java world. And it was like, hey, write once, run anywhere. We have this VM that will handle all of that, like machine architectures and stuff under the hood. And all of that stuff became either bloated or slow or people didn't like it, went out of style. But there's still like Java and Postgres still run the world. And that's still like very much a thing.
I'd also like to just put it out there that Java's got considerably faster. Just want to put that out there.
Well, if anyone can upgrade from Java 12, so like everyone's still back.
It's 8. And I mean, I think like the world will like blow up before it fully dies, but that's not the point, Justin.
I was like, I remember running Java, I don't like 4 or 5 or something like that. And like we had these Tomcat apps like, hey,
but I mean, Java's also done a lot. Like they've like increased how you're going to release every 6 months. So that problem does not continue happening, smaller releases, smaller jumps. But honestly, I've never used WebAssembly, so I do not have the context to compare the two.
Well, that's why I was curious. I wanted to know either Autumn or Danielle, like if there's like, if this promise keeps repeating itself, like is WebAssembly the new Java?
Isn't that kind of just like tech in general? Everybody wants to do the new cool thing, and then half the time they don't even use the old cool thing. They just come up with a new cool thing because they're like, I have the most brilliant idea ever, and nobody's ever done it before, and they have.
When I speak at like very enterprise conferences, I describe WebAssembly as like fast CGI for the modern era. Partially just because, that is basically what serverless is. But also the execution model of WebAssembly is so close to that. Java is always interesting to me, partially because like Sun needed Java to succeed like existentially. And then, well, there's a reason why you can't go work at Sun Microsystems. But Java did a lot of really interesting things. And I think part of the reason the JVM could never really like be all it could be was because it was so tied to Java, the language. A lot of stuff now exists that, will run like Python on the JVM and like whatever. But a lot of that is sort of very new. And Java has its own like big set of like bloaty problems and people that need to understand how to tune and work on all of the bits that let the JVM be good. But you don't see the JVM really scaling down effectively. I mean, like Java card exists, but like that's not the JVM, is it?
I mean, it is a full VM, right? Like the Java VM.
I have a question though. When you want things to be more secure, right? Like there's always that balance between security and like unusability. Have you ever ran into like any like of those type of issues? Because you're essentially putting a cloud in a box, right? So like what were like your main struggles, I guess, in putting it in the box? Like where did you have to make the choice of like secure versus usability in that process?
So the joys of having already thought through a lot of those problems is that like there's not a lot of new trade-offs really when you move from the cloud to putting it in a box. Because the way we think about building configuration and applications in the spin model, where you're already defining the things you want, and then at an infrastructure layer, you're saying, here are the things you can actually talk to, and you're mapping those things together. There's not really a whole lot of like serious security trade-offs in that bit specifically. The thing I'm actually really struggling with is finding the right layer of like expressive infrastructure configuration and mapping that back to the developer programming model. Like it's a really big DX problem more than it is like a technical problem. Because when you're giving things people to run in their own infrastructure, the like sort of combinatorial problem of like interfaces to backend things is so much broader, and trying to figure out like the right level of this is something your infra team should own versus this is something the developer should own the decision of is really nuanced. Like one of the things that I want to model in our Kubernetes stuff eventually is the concept of like a default data store. So in Fermyon Cloud, every application gets access to at least a quote unquote default key value store, which is really nice to rely on because it means that every component can assume that it has access to some form of cache. And like in building a lot of applications on top of that, it's a really powerful assumption to be able to make. And we want to be able to bring that kind of thing into Kubernetes. And so it's what I'm thinking about is how do you give that kind of magic to someone without making them write a ton of YAML? Because, anything that is a configurable knob is something that will be off by default. And then you can't rely on that assumption anymore. And it's really hard to get right.
Especially generally right? Because like if you could get something right for a specific use case or for a certain type of developer application, like, this is the right way to do this thing.
What's right for one person, someone else absolutely hates.
Exactly. and then once you're generic enough that you're like, hey, everyone should do this. And I think that's going back to like the Kubernetes networking model, right? Because one IP address per pod was right for a certain type of application. And as long as it's one application instance for that network IO, we're fine. But once you're shoving a Wasm runtime into that pod and then saying now you are 5,000 applications, that model isn't the right default anymore.
Hey, for one person, it's a feature, another person's bug.
The load-bearing bugs are the hard part, right? Like when someone's like, this needs to work this specific way, otherwise I go down. That's a problem.
The $1 million bug.
It's so hard. Like, it's the like having run enough things in production to have like a lot of empathy for, the tired operator who has been handed this thing by a dev team and been told to make it work.
That's why I think like when people are like, you can't just say it depends. And I'm like, yes, you can. Yes, you can. like if you have like, when anyone speaks in total absolutes, I'm always like, that is some confidence I don't know if I have for anything. Maybe
I
it's just
know.
like girl in tech, like imposter syndrome, but I'm just like, absolutes are very hard for me. Like, I'm like, majority of cases, if you do X and Y, but like, I don't know. Because I'm not surprised when something is like, for me, this was horrible.
I remember a long time ago being the excited person who would like read about something on the weekend and then want to do it. And I'm now the person who like sees someone say that and goes, not here.
As long as the pager goes to your phone.
I was that person for years, and then now I'm just like, can we just do it as simple and boring as possible? I do still play with those things on the weekend and build something random that I won't get paged for, but
If I'm thinking of, we want to hire someone and all of their resume is just EC2 and Postgres, like that is an instant hire. Right? Like
dude, because they know all the things, right? Like,
you're like, here's the 10 things I built, all of them with EC2 and Postgres. I'm like, good. Come on.
It's so funny because like I feel like everybody wants like to get a job in the new cool thing, and I'm over here like, what is the most boring legacy like hole I can go hide in until this like AI thing is over? No shade to AI, like I want to use it, but I just want to go crawl into like the most boring legacy. Like,
have you asked ChatGPT to give you some recommendations?
I'm gonna go do that, Justin. Be like, what do you not touch? Like, tell me the secrets.
I am like really enjoying the space I found myself in though, where I get to like build the new cool shiny, but with like the most boring choices possible.
Those are the best new shiny things though. Like those are the shiny things I get excited about because it's like,
I hate the like, sparkle points or like innovation points analogy, but it works so well.
well, and it also just sucks because like I do think some things are super interesting about it, but now I'm scared to even touch those things because what happens when it bursts? You know what I mean? So it's not even like a shade to the new shiny thing.
Oh, I haven't even tried ChatGPT.
What?
I'm like, I'm too boring for this. Like,
My boyfriend hasn't tried it either, and I'm like, you work in tech, and I'm just like, how did you escape it?
In Fermyon Cloud, we have like an AI thing that like I help design, and I'm like, I have no personal interest in using this.
See, I love trying new things and new tools. I just don't know. Like, I very much believe in like use the tool that you need for the job. Like every database does not need to be a NoSQL database as much as I love them. Java's not always right for stuff just because it's my favorite. But like, I think like people just don't know how to like, in art, we have this saying, and it sounds horrible, but it's called kill your ugly children. And you have to accept when something doesn't work and it's bad. And people don't want to do that. They're like, I used it once and I have to use it for everything. You're like, dude, no, you don't. Like, just put it down and it'll be okay.
I still remember the first time an art teacher told me to throw away a sculpture I've been working on. And I was like,
that's why art kids do get great in tech, because we know disappointment, okay? We know having your dreams killed. So we're just like, it's cool. I may have spent like my life on this for 2 weeks, but like I'm used to being disappointed.
Yeah, it's like I just spent like 12 hours like shaping this eyebrow. And you're telling me to throw it and start again.
Yo, art teachers are savage. They'll be like, it's horrible. Get rid of it. Start over. And you're just like, but I just put my whole life, that's like my life's work. And like, I love it. And it's like, nope.
Yeah. It's like one of the fun parts of shooting film too, is like, it's this very like analog chemical process that sometimes just goes wrong for completely random reasons.
Okay, but is that not very related to building software though? Like that's what, like when people are like, you have to have like this fancy degree from like this fancy school, and I'm like, but do you? Like sometimes having people with other backgrounds, that have like sometimes I'm telling you, some of the best developers I know have like the craziest like theater background and like all kind, and I'm just like they are fire. Like their brains work in ways that you're just like, how did you get from point A to point B? Like I'm just amazed.
I'm a high school dropout, and now like half the world runs my software. It's cursed.
That is badass. Like, sorry, we're gonna bleep that out too, but like I'm such a fan now. Like I love me a like beats adversity story. Like all for it.
Danielle, thanks so much for coming on the show today. Where can people find you online if they wanted to reach out and chat some more?
I moved to Mastodon because that's where all the cool kids went. But if you go to links.danielle.fyi, you find me in all of the places.
Come to Blue Sky.
I am also technically on Blue Sky at danielle.fyi.
Come back.
Well, we'll link that in the show notes for everyone so they can see it. So thanks so much for coming on and explaining Wasm and Fermyon's cloud to us.
Yeah, I'm sorry that I am an unprepared mess. It's
No, this is great.
I learned a lot.
We wanted a conversation to walk through it. It was awesome.
Cool. Wow, this has been great.
Thank you so much, Danielle, for coming on the show and telling us all about the backend of Fermyon and WebAssembly in general. And it's just such a different mindset when you think, oh, I'm going to shove 1,000 applications on a single instance compared to, back in the day when it was like one server, one application, containers, Kubernetes, like, oh, I can get, like maybe 100 or so. And they're just like, let's just change how this works and get 1,000 out of it. That's just really cool.
We talked for so long that I think my computer died. Like,
Yeah.
Even after you got off, I was like, I had so much fun talking to her. She was amazing.
So for this outro, we're going to go into WTA, which stands for What the Acronym. And we just want to explain some of the acronyms that were either in the episode or just in general around WebAssembly, because if it's a new space, it is a very new space for a lot of people. It wasn't even really announced until 2015 when it came out of Mozilla. It was a evolution of asm.js, and ASM stands for assembly. It's like assembly code, which is the machine code that you can write on, which is usually like compiled to your processor.
Yeah.
And in higher level languages, like, oh, I don't need to like compile to my 8086 anymore. I can compile to like any processor, and the the compiler figures that side out of it was amazing. Like that was a big step for development and how programming works. And shout out to Grace Hopper for making COBOL, back in the day, to having these like higher level languages that you can just write once and compile them multiple times. So ASM stands for assembly. And again, like, I actually don't know why. Like, it's not, there is an A, an S, and M in there, but like, why those 3 letters out of assembly? I don't know.
I'm not sure.
But WebAssembly is Wasm or WASM. And if you're reading it or writing it, usually the acronym is all capitalized. Not all acronyms are fully capitalized. And also when you're writing WebAssembly out long ways, it's one word with the W and the A camel cased. So just FYI to get those things right sometimes. It looks better if you're correct in how you're spelling it.
It's really cool meeting different people and learning about products and then seeing where they come from. Like I wouldn't have, like Mozilla came up with that, and just seeing the things that have come out of Meta and all these different places, and then they create something and then open source it. It's really cool.
Yeah, and really the beginning of asm.js was all about getting a smaller subset of JavaScript. They wanted to minimize the amount of what JavaScript is a big language, and how do we take just a small subset of JavaScript and then we can compile it, and we can take it and we can actually just run it at more native speeds, because JavaScript is an interpreted language. And when you're moving text files around and then trying to interpret it and just in time compile it, those are all things that just take time. And it's something that machines like, hey, what if we compile this up ahead of time before we send it to a person? We can make the file size smaller because it can be actually like in bytes, not in text or ASCII. And then we can also the machine can read it and it can just start executing it. And there's all these steps you can kind of avoid. And then by minimizing all of the JavaScripts from not everything, but a smaller subset, you could say like, oh, like you only write a small subset of JavaScript, but then we can compile that and be really fast about it, because we know how that's going to compile into what our runtime is going to execute.
Not to like defend JavaScript. I can't believe I'm defending JavaScript, but I mean, I think it's because it started off for one use, and then people wanted it to do so many different things and to be object-oriented programming, and it just became so much to do so many things that it just got so big.
And WebAssembly has followed a very similar trajectory, where JavaScript was first designed for the web browser. WebAssembly ran in browsers, and it was targeted for browser environments and how we make web apps faster. And then it kind of shifted into this, like what Node.js did for JavaScript, right? Where it's like, oh, we can run this on the server, and we can say like, oh, we have a runtime that runs outside of the browser. And how does that work? And that's what a lot of the Fermyon and the WebAssembly like cloud environments do. We're like, hey, we're running executing code that runs services. And most of the time, these are like functions. These are more like Lambda functions or function as a service, where it's just executing one thing and then dying. That's how like Cloudflare Workers and Fermyon works. There are some that are starting to do these like long running processes, more like a traditional web server like Nginx. But that gets into the next acronym of the WebAssembly system interface, which we did mention in the interview. The WASI, WASI, is that interface of how it's kind of like the Node.js of WebAssembly, of like how does this thing that is intended to run inside of basically an operating system, right? Like a browser is an operating system to many degrees. It has isolation. It has all this runtime stuff that's built into the browser. But what if we don't have a browser? What if we don't have Chrome or Firefox? And so you need another runtime engine that can execute this code.
That's like when people try to argue if a hot dog's a sandwich or not, and then people have these debates on Twitter for like.
People like debating things.
They
don't
really
they?
Sometimes you're like, why do you care so much?
Those people should just get kids. Is my hot take today? It's just like if you have,
so they can argue with tiny versions of themselves. I feel you. I've been there all weekend.
If you like to argue, go have a 7 to 12-year-old. I don't know, somewhere in there. I'm sure older and younger it happens, but I feel like there's like a sweet spot in there of like, you know what? They know enough that they know how to argue it, but they don't know.
Does your kid ever say something that feels so much like yourself that you feel like you're arguing with a smaller version of yourself, and you're just like, I can't believe I made you and kept you alive just for you to argue with me and tell me how terrible I am.
And that's when I just say, alive. Go to your room. Yeah, that's
like, I'm sorry I fed you.
A couple other acronyms here. We did mention just-in-time compilation. JIT is a common way to abbreviate that, as well as.
At least their acronyms like kind of sound cool. WASI sounds cool.
Yeah, it's hard when someone's saying it, right? Because if someone says like, "Oh, it's JIT compiled," you're like, "Well, if you're not familiar with it, like you're taking the code and interpreting it and compiling it right there." That's kind of what Python does, right? Like Python's not running the text files; it's compiling it just in time. Ahead of time or AOT compilation is what you do with like a Rust or Go or something that's like, "Oh, I'm going to make this binary, and then we're going to ship the binary out." WASI interfaces was tripping me up because WASI is WebAssembly system interface, and then there's an interfaces on top of that. Like
it's an interface.
Yes, it's like ATM machine. You have an automated teller machine is how that works, and so it feels a little redundant. But the WASI interfaces is just like general categorization of how your code is going to interact with a wider system. And those are things like input outputs for, like streams, clocks, random file systems, sockets. There's a couple other ones. What are those? CLI and HTTP. These are all different interfaces that your application says, oh, I need the file system. And so I'm going to use that interface, and those get declared in what's called a WIT file, WIT. Again, these acronyms they're all W's, and they just keep, all Kubernetes stuff is K's, all WebAssembly is W's, and a WIT, a WIT file, is a WebAssembly interface type. And so you define that as, hey, I need to use this interface. And then when the runtime is going to let you run, it says, oh, you can or cannot access that thing, which has good and bad parts of it. Because if I'm using the runtime and say, hey, I want to interface with a database, then it doesn't matter what the database is on the back end. I need a SQL database. The runtime can interface and say like, oh, well, you can get MySQL, you can get Postgres, you can get whatever I tell you is this generic database thing. And that can be really good from an application developer. You're like, I just need the generic thing, but can also be bad
when you need something specific.
Exactly. You're like, I need this specific feature from this.
It's always that caveat.
Yep. It's easy to write and deploy as long as you fit the mold of what they're providing you. And as soon as something's different.
Because the second you don't, it's going to get real.
Yep. Then you have to control it. Yeah. So for now, the WASI interfaces are categorized in these different types, and your runtime can provide that into you as an application. But those are all still pretty new. Those are all they're very new. There's like 0.2 specification of these interfaces.
When
so they're still evolving.
Interface, it just made me think about the fact that JavaScript has 3 equal signs, and that just hurts my soul every time I see it. Like a little part of like me dies.
The last couple things I want to talk about was some runtimes. There's Wasmer, which is WASMER, which isn't an acronym.
I'm here for how it sounds. Like I don't.
Wasmer.
Yeah, like Their acronyms are very cute. I don't know if I'd would guess any of these things from the acronym,
Right.
but you know.
And that's why we're here. That's why we're explaining this stuff.
Yeah.
So Wasmer is a runtime. So again, you can execute your Wasm bytecode and is created by the Wasmer company. I actually don't know. I couldn't find who's behind the Wasmer company, but they make a runtime named after themselves. But they also make WAPM, WAPM, which is the WebAssembly package manager. And this is kind of a registry of reusable bits for WebAssembly compiled code. You can think of this as any sort of registry, something similar to maybe a Terraform, modules, or Docker Hub. The downside is this is very, very new. And so when I looked at it, there was only 1,000 packages out there. And there was only a dozen that looked reasonably useful. A lot of them to me were just I have no idea what that does. It seems like someone just uploaded a package just to see how uploading packages works. So looks a little bit promising, but again, another acronym that you might want to know because they have a command line tool, WAPM, to install packages from their registry.
I feel like half of tech is algorithms.
You mean acronyms?
Acronyms. Ugh. This is what happens when you've been at home with your kids for 3 days.
Yeah. They suck all the think out of you.
Oh my God. My brain used to work.
Well, it has to work for Tuesday.
Putting them all to sleep so early.
Yeah. It's 7:00. Go to bed.
Go to bed.
The last one I want to talk about, the last runtime, is Wasm time. And this one is created by the Bytecode Alliance. And the Bytecode Alliance is a nonprofit that is trying to push the specs forward for what WebAssembly is, what WASI is, and they created Wasm time as a runtime for WebAssembly. And the Bytecode Alliance, I couldn't tell if they were a sub-organization. A lot of them are part of the Linux Foundation.
Yeah, that's what I'm trying to understand. What is the hierarchy or the way this is all structured?
So anyone not familiar, any sort of nonprofit or foundation that kind of does this stuff, like Cloud Native Computing Foundation, all of the companies that are part of it pay money. They pay a lot of money to be part of it. They get a seat on the board and they can set the direction for what that foundation does. And so some companies on the Bytecode Alliance board or part of the companies that pay into it are companies like Amazon, Cisco, Microsoft, Intel, Docker, ARM. There's a bunch of them. There's a bunch of big names that you've heard of and a bunch of smaller companies that are really specific in this space. And they pay money into it so they can have a seat at the table. They can say, hey, this is a priority for us. We have to make WASI, the system interfaces, really good, or we need an interface that does this. And they put the money in, they control the direction for it, and then they also can help add developers and have ownership of some of the projects, right? They're maintainers. They built Wasm time, which is actually a really interesting thing as a person working at a large company. If you want to work in open source and you want to work as hey, I want to give back to the community, this is one of those ways that usually it happens. As I used to work on the EKS team at Amazon, and a lot of what I did was open source because a lot of the community was open source first. And being in that environment makes it really easy to say hey, I don't actually contribute internally to the code. I contribute externally in the community. And then we pull that, whatever I do externally, we pull that back in so we can use it.
It seems like more and more that's where it's going, and I hope that's where it continues to go.
Yeah, there's definitely some larger projects that need that kind of guidance and really that kind of funding, because the stuff doesn't happen with no funding. And actually, that leads us right into the very end of here, where our next week episode is going to be with Gina, who runs Octoprint. And that is one of those completely community funded, no foundation donations provided to create great software that she's been creating and building and running for, what was it, 15 years, something like that, more than 15 years?
10, I think.
She started doing it full time 10 years.
Yeah,
that's right.
10
It was
years
a
ago,
hobby
15,
yeah.
It was something she started on a Christmas break, I think.
Yeah.
Gina's amazing. She talks multiple languages. She is the sole maintainer.
And not just Python and...
Yeah. She's just amazing. She's just and then I solved this problem and I found this problem and then I made this solution for it. And I'm just you are just a legit problem solver. It's amazing.
Yeah. So thanks everyone for listening. If anyone is around any conferences in June, just a heads up, I'm going to be at a couple conferences on June 22nd, a few weeks after this goes out, at SRE Day in San Francisco. And the 26th and 27th, I'll be in Seattle at Cloud Native Security Con. I have talks at both of them. So if you're around and want to say hi, I have some stickers that we can hand out, and we'd just love to meet anyone and see what you're working on and what software you're learning.
Sneak me in to the security one in Seattle so we can like record an episode. It'll be fun.
Well, we'll have to figure something out. So for sure, I'm going to be around. So definitely let me know if you're there, and we will talk to you all next week.
Bye, guys.
3, 2, 1.
Thanks for listening to Ship It with Justin Garrison and Autumn Nash. Subscribe now if you haven't already. Head to shipit.show for all the ways, or just search for Ship It wherever you get your podcasts. You'll find us. Thanks once again to our partners at fly.io, to the mysterious Breakmaster Cylinder for these dope beats, and to Sentry. Use code CHANGELOG when you sign up and save $100 off their team plan. That's all for now, but come back next week when we continue discussing everything that happens after Git Push.